So we will have four sections inside our presentation, me, and after there will be Damiano Corcoruto, that is our project manager and CDA manager, talking about BIM specialist. After that, there will be Simone Noro, that is our project structural design manager. He will talk about an experience of a stadium in Paris. And the last one, but not the least, is Margherita Roverato, that is our project manager and BIM manager, talking to you about the multifunctional sport arena in Rome that we designed for ex-CONI, now is Sport e Salute, so the Italian public entities that manage our sport. So Linda probably know very well. This is in what's the name? Centro Giulio Onesti. You know. Okay.
Hello, everybody. Nice to meet you.
Hello.
Nice to meet
So
you.
Ciao, ciao. Ciao a tutti. Nice to meet you. And we went in Rome last July for our workshop here in Centro Giulio Onesti.
So you probably saw this multifunctional arena. That is the last one that has been built probably in this facility last year.
Penso che possiamo partire, Gianluca.
Okay. We share the presentation with you, all of you.
We will take a look to the website to Incide, because I think it's quite interesting to understand, to discover the reality of this company. Sigmund, bella la maglia. Mi sente.
Have we any limitation? C'è qualche limitazione per la condivisione? No.
Non dovrebbe verificare.
No. Okay. Now I...
Dovresti essere già
Sì.
relatore.
Ok.
Perfetto. Vedete tutti? Io vedo? Sì? Ok.
Okay, this is not a proper lesson, as I told you, but it's an illustration of our experience. Okay, just to let you know my name is Gianluca Vallerini, and my role in my company is I'm the CEO and the founder of the company. Incide Engineering. Okay, the person that will speak I already told you, this is the summary of today's presentation. We will stay together all the morning. I don't know if there is some pause, some interruption that is already planned. Normally, what is the schedule? So 1 hour and a half after which you stop in 10 minutes, or what?
Now, usually we have a break in the middle of the morning, after 2 hours, 11 and 15 minutes.
So, okay, so we can say after the Damiano presentation that is in the middle, we will have a break.
You can manage the time wherever you want.
Okay. So this is the summary of the presentation of today. As already told you, this is the person that we meet, and talking about a little bit about me and about my company, just to let you know who Incide is and the experience that we have. Incide or Inside or Incide, depends of the language that we are talking about, means industrial and civil design. This is the history. The company started 25 years ago, so we can say that we are a well-skilled, well-established design firm in Italy, but our company not only in Italy. Our experience goes through different countries in the world, and also we have some family companies in three countries. One company is in Switzerland, in Lugano. One company we have in Paris, another company we have in Morocco, in the capital, Rabat. Incide is a multifunctional, multidisciplinary engineering firm. So inside our company, there is all the experience that permit us to develop the design. So going from architecture to structural design to MIP, we can develop totally inside a project. Also, if it happens sometimes that we collaborate with other firms, architectural firms, structural firms, it depends on the size of the project. Sometimes we develop totally internally the project, sometimes we collaborate with other company, especially when are talking about a big project. And as I told you before, we have a good relationship also with American firm. We are working with a couple of Chicago design firm, but not only. And our experience go from Middle East to Europe to Africa. The company works in different sector, not only in the sport facility, but different sector of building. Mainly we design building, and we go through aviation experience, commercial building, residential building, industrial buildings, infrastructures, and sport and spectacle, because sometimes, most of the time, the sport facility are not only built to host sport events, but mainly to host all those different type of events. Especially one of the project that we illustrate today, that is the sport rugby arena in Paris, was planned for this type of event. So rugby is the main focus of the arena, but most of the time it's used for concert, is used for spectacle. So this is the new view, in the modern view of the sports facility. These views allow the owner to get bigger revenue using this facility in different way. About our expertise in sport design, we can, as you told me, we can design different type of sport facility, going from multifunctional sportive arena to entertainment hall, football stadium, and also theater. So there was a very nice experience that we did in Morocco, in Rabat, for a theater of design with the architect Zadid. So very complex design in terms of architectural shape, and all this type of facility has many things that are in common. So the principal things that is in common is that this facility hosts a lot of people, and these people is going there to look a spectacle. So that could be sport or could be a concert. So mainly this type of facility has a common rules in order to start and develop the design. These are some experience, just a little summary, and from this experience there will be some experience that will be illustrated to you. But my presentation of today starts from the technology that now in the design we are using. I don't know if probably all of you knows what does mean BIM and what is BIM technologies. This is just a question for you. All of you are aware of BIM, or there is someone that is the subject completely unknown? You can answer.
Please interrupt. I can't answer.
Sorry?
Do you understand the question? Yeah.
Yes, I do understand them.
So
There is anyone that would like to tell me if know what does it mean with BIM knows and what is the BIM technology used in the design, or just to understand if what I'm illustrating to you is something that is you know or not.
I've heard about BIM, like just basic, but not in depth.
Okay. So again, it's good. In any case, now I would like to go through what is the design technologies, and talking about these new design technologies, that is building information modeling. That is the new way in which now normally the design office develop the design. I would like also to start having a look at what is in the past our job. From those pictures, you can see that the design office in the past was composed by big spaces. You having people that develop the design, having by handmade, and also me. And in the very beginning, I started to work in such a way. After the technology arrives and everything changes, but these changes as will be developed step by step. Now, going to the future and looking what is now the design office. Now, design office is completely different. What from the picture that we saw before. Now we are looking to the new technologies. All the new technologies are going in our way to works, and also in our office we are looking to all what could be the futures. Now all the world is talking about artificial intelligence, and for sure it will be necessary to look and have the competence to use these technologies. Otherwise we'll be out from the path of the future, and this has to be done step by step. BIM, what does it mean? There is from Wikipedia a state that BIM is building information modeling, is a process involving the generation and management of digital representation of physical and functional characteristics of place. Building information modeling, BIMs, are files, often but not always in proprietary formats and containing proprietary data, which can be exchanged or networked to support decision making about the place. What does it mean? Now we are not anymore using paper in order to develop our project. We are creating digital twins. Digital twins, what does it mean? Are 3D representation of the reality, but this 3D representation of the reality is not only a geometrical appearance, but mainly are data that are included in our model, and from this data we can obtain many things, not only drawing, but as we can see later, we can use this model in different way and different part of our process. What the design is composed by? Normally is composed by drawing, is composed by technical specification, a bill of quantity. In general, from our job, we produce this type of these documents. And since now in a construction site, those are the document that arrive on the table of the construction company, and that will be used in order to build. Also, this aspect is going to change in the future for sure, and this is the future of our job. In the construction side, there will be no more drawings, technical specification, or bill of quantity using paper, but we will have and we will manage the process of construction using the 3D models that already now we are developing. Going back to the history, I like to show you some pictures. This I don't know if you recognize what could be this project, this drawing coming from which project. Anybody of you can recognize from this detail what would be the construction that I'm talking about?
Eiffel Tower.
Yes, yes. This is a very, very nice example of a design history. So this tower has been built in the beginning of the century and is a very complex project. Anyway, has been built very quickly and the design is very complicated without any new technology. So to say what? Say that in any case, what is very important is also the engineering experience and the human capability. And now we have a lot of tools that permit us to facilitate our design, to construct our project very quickly and in a very safe way. But in any case, the human capability, the human knowledge is something that I think that remain as to still the things most important for the future. So the artificial intelligence is something that is coming, but I would like and I hope that will not replace our intelligence. And what could be the changes that we had in our job? Since 1982, the drawing and our design was done by using handmade drawing and with method of designing line, arches, circles, and there will be only 2D isometric view. So this is the past. After 1982, the CAD arrived, so computer system aided design. The computer arrived, so we can develop the project using CAD. But the way to develop the project not changed so much. In any case, using CAD, we do 2D drawing, sometimes 3D. But they are only representation of geometrical representation. The big changes arrived with the BAM from 2000. What happens now? We are not anymore making drawings. We are developing 3D models, and we are not making lines, but introducing our models walls, beams, columns, so objects that represent the reality of the buildings. And what is very, very important also that these objects are not only geometrical objects, but inside of these objects there will be many information that can be added. The software, the tools that we are using permit to introduce in the object physical properties, material properties, all the information that is needed and used for other analysis. From the model, this model can be exchanged from architectural model to a structural model, from architectural model to energy analysis. So this is a way to put inside of this object all the information that can be used, and also in terms of cost of materials. So the model, the BAM model, now can be used for all the aspects of the design. So all the design phases can be developed using BAM models. So from the 2D drawings, as I told you before, analyze different type of analysis. Also bill of quantities. Bill of quantities means how many kilo of steel or how many cubic meter of materials. But at the end, all this information can be used also for the future, for building management, having producing fabrication detail, and also the model can be used for project management. So different part of the design and different part of the process of the construction can be managed using our model, and this is what we are looking for the future. So now we are in Incide, we are using BAM since more than 15 years, and all our design has been developed using this technology. The limitation that we have now in the process, that after the design in the construction site, there are few companies since now that are using this model in order to manage the process of construction. So this is the future, and for sure we will arrive in such a situation. So all the process of the construction can be used using BIM, as I told you, design, construction, and also building management. In the BIM, there are several dimensions that has been used. Okay, the 1D and 2D are the traditional CAD dimension. With the BIM technology, use other 4 dimensions. The 3D dimension is a 3D representation. 4D is called the dimension of time. So we can also introduce elements that help us to produce the time schedule of the constructions. 5D is the dimension of the cost. 6D is the dimension of performance. So with all these 4 dimensions, we can manage all the process, and we can add all the information of the process, of the design process. What is also the other big advantages of using this type of tools? Perfect coordination of drawing, perfect coordination of design. All the aspects of design are included in the model. So since the very beginning of the design phases, we can check and manage the coordination between architectural, between structural, between MIP. This was completely different from the past, in which any discipline works separate. So the architecture develop its part, the MIP develop its part, and after the moment in which the drawing has been produced, only in that moment there could be the coordination between the disciplines. As you can see, this is an example of a 2D drawing in which using hand sketches, person sitting on the table, making coordination of the different disciplines. Using now BIM, in which different persons, different disciplines can share the model using the cloud. That is a normal tools that we are using now. And also work in different places around the world, that we can coordinate and work together, having this type of coordination in a moment, in the early moment of the design. And this is a very nice help for our job. So at the end of the project, the design will be perfect coordinated. Okay, it's well coordinated. In any case, the error is a human error that never disappear. But in any case, we can anticipate a lot of the problems that normally arrive during the construction phase. And during the construction phase, the error that is coming from the design has a cost much more affecting that to solve this coordination problem during the design phase. So it is a very big help. So the benefit of using this type of process is saving time, find mistake, and manage interference during the design phase. So not having big problem during the construction. So the reducing also cost, and so cost optimization. And with our experience using this type of tools, we can say that effectively this benefit is something that we are having during this 10 years of experience using this this process. But as I told you before, it's for me it's very important that human ideas, human experience has to be, in any case, a central part of our activities. Any question? So I don't want to speak for 1 hour and a half without having discussion. So if there is any person that has some question or some curiosity, please stop me. Okay, I go ahead. Another important part of the development of our technology now is the possibility to exchange this data that is coming from a 3D model, from BIM, with different software on different part of the project. This is called interoperability, and this allow how to use different softwares for different type of analysis. This is possible from.
What do we mean when
there
we
is
talk
a
about
little
Open
video.
BIM?
So.
Well, Open BIM is a format of building information modeling that uses open standards, providing several key benefits. First, every project member is able to use the best tools for their particular workflow without being locked into one vendor. Second, any stakeholder can access the BIM model without interfering with the native design. Third, all the disparate systems being used on a BIM project can communicate with each other. At the heart of Open BIM is a standardized communication protocol based on Industry Foundation Classes, or IFC. With this open framework, data travels easily between technologies. This allows AEC professionals to use the technology of their choice without the limitations of proprietary data. This leads to benefits that improve cost control, productivity, as well as reducing waste as the project has more efficient handoffs and fewer communication errors or data gaps. For more construction content you might dig, subscribe to Constructible.
Okay, in this video, there is a summary of what I said before. So now there is a possibility to exchange this BIM model using this common format that is called IFC. So we can extract from one software an IFC model. This IFC model contains all the information that we introduce in our model. So, for example, what we normally do in our design, that we are using the architectural model as a big box in which we introduce information not only for the architectural design, but also for cost information, property of materials. So exchanging this IFC model, we can use this IFC model with another softwares for structural design, for example, or energy analysis. So, and this is a process. This is a process that any company is creating in accordance of their technology, and having this process more stable is possible to connect this information more easily and have a flow of our design very quickly. So this is also in which we are working. And the future of the next one. And the future of the using this type of softwares, this type of tools, is also to use for the entire process of the design. This is not a sport facility; it's a towers that has been designed from our office in Milan. And this experience started from an existing building, which we developed the survey. Survey has not been developed using manual tools, but using laser scanner. So after the laser scanner, we transformed the laser scanner result in a BIM model. And after we start the design, so inside the model has been introduced all the elements of the design, MIP, especially that has a big impact in the design. So all these elements has been introduced properly and without creating any problem during the construction. Also during the construction works, the model is being used in order to check what the design, to check the interference. But now we are using this model as a digital twin for facility management. So the model represents the reality. This model has been given to the owner of the building, and inside of the object there are information related to the management. So there are information about data sheet of the material. So during the management, and the person can have information about the material that is already installed, can have information about the time in which they have to check this element during the times. And with using this tool, this type of activities became more easily, more friendly, and using also what's the name? Business intelligence tools. We can have a report of all these maintenance activity, and also using using sensor on the equipment. We can have information about the consume that the machine has in the building. So also the energy consumption of the building can be checked and properly maintained and have a monitoring during the time of the building. So this is the one of the most important result of the technology that can be applied to the use of BAM. So starting from the design, this model can be used for all the process arriving to the facility management. And this is not is not only a vision, now is something that is already a reality, and we are using these tools in our process. Okay, sorry. Now I would like to tell you about the first case history. This is an experience that we have of a soccer facility in Torino, in Italy. This was a project of the renovation of a historical stadium. This was the stadium, the initial stadium of the Torino soccer team. During the history, the soccer team was abandoned. As you can see on the picture on the left, the soccer field was in agriculture area. There was no building around. After the growth of the city, as you can see on the right low, the soccer field was completely included in the city, and during the time it's being abandoned. So you can see some picture where the tribune was in the condition the tribune was left. There was a tender from the Turin soccer team in order to rebuild the stadium with the idea to maintain, to recover the initial view of the stadium. So this was the main goal of the project. As I told you, also this project we developed using this technology of BAM. So has been developed a full model, including all the aspects from architectural to structural to MIP. And from this BAM model, all the analysis has been developed. So energy analysis, structural design of the steel structure and the concrete structure, and also MIP calculation, electrical design. This is the architectural. Architectural means plans, normally means plans, but also normally means 3D representation and renderings. We had very good views, and that's being appreciated for the client, and also perspective and views, elevated views of the project, but at the same time section and views. So all these representation came directly from the BAM model. So we developed the model, and from the model we can have all these representation. And also we can have representation of details. So the details are very important because our design is normally going to final design, means that we are giving to the client properly information of how the construction has to be built. So they are not only general information, but detailed information. So you can see that also detailed representation of the construction is included in the project. And details means not only geometrical representation, but also information of the materials. From the BAM model, using database and using standards, we can have information of all the elements that we are included. And from this information that are part of our design, we can also have information about the quantities. So everything is included in the model. In the past, we developed 2D drawing, and the information about material, information of the quantity and the property of the quantity is a part of another section of the design. Now, using this type of approach to the design, everything is included and everything is well coordinated. But
Sorry,
at the same time,
sorry, Gianluca, no, just a curiosity for me. I think you should make a specific library for the stadium for a sport architecto. Is your own library is built from your office specific, or is a library that you can I don't know, buy, or you I don't know.
This is a very interesting question, because we was discussing about this issue a few days ago with colleagues. This is what is strange, that especially in Italy, not in all the other world, that any design office is developing by yourself their library and their organization of their project, not only using BIM but also before using CAD. Also speaking about using CAD, there was a necessity to establish layers. No? Layers in Italy is everybody has his own layers, and this create problem also exchanging drawing between the different companies. We learn working with the American design firm that in America there is a much more common organization about this library. For example, layers for CAD are the same all over the United States, and this is a very simple things and the stupid things that in Italy we have UNI, that is the organization for unification of standards. We are not developing a common standard for all the design office, that we are doing the same job, we are doing the job in the same way, and everybody is wasting time to create their own library. And the problem is that when we are exchanging our now model from one office to the other, there is no common information. The information are not the same. This is something that has to come for sure, not from any single design office, but has to be planned for a national organization. So there will be many waste of time, reducing of cost for any design office, and more possibility to exchange this model, this information through any office without also thinking that this is something that is your own value. This is the reason why also we are having problem with starting a project from something that is already designed from another office. So there is a little bit of exclusive in what we are doing. So answering to answer to your question, it's our own standard, and it is something that is a little bit stupid from a general point of view.
Yeah, thank you, Gianluca. I think it's a very interesting topic to develop,
yes.
to study also in university environment. Very interesting.
Yes, I think that so this type of organization, university, or also ordini degli ingegneri o degli architetti, talking about our organization that manage our profession, has to manage this topic, because it's a very simple things, because how we do something is probably similar or the same that our colleague is doing. So having the same library, having the same organization of the project, it could be very create more efficiency and possibility to exchange the design very quickly without not having necessity to adjust what is receiving from another office. So thank you for your question in the case, because it's very interesting. And going ahead, so we are introducing all this information, having created before our database, and Margherita is our BIM manager, is one of the persons that in our office has worked, and also Damiano, to establish this database. And we are still working, because it's not something that is a job done. So improving your job and doing something that is different, you need to improve this database. So day by day we are working on this subject, also because the technology changes. There is something of new that we would like to manage in terms of talking about interoperability or new technology that we are implementing in our design. And so this is continuous job that is undergoing. At the end, the result of our design is to have as a sorry, so there is a video. This is the BIM model, the complete model developed for the project, in which there is all the information that allow us to present the project. We are not still in the phase in which we can deliver to the project just the model. So that probably this will be the future of our job. And now we are delivering drawing and technical specification, bill of quantity, and at the same time also for certain type of project, big project, we are also delivering to the client the BIM model. The client is not still aware what he has to do with this model, but this is the rules that we have in Italy now, with projects that are more than I think 10 million euro project is we are obliged to deliver to submit to the client also the BIM model. So this model has been developed perfectly coordinated. Everything is included. You can see also there is for this soccer field there is also the heating of the field in order to avoid the ice during the winter season. And so it's a little facility, because there is not a big tubing, because this facility is used only for training, and for training for the main team and for the junior teams to play. So the tribune is not a big tribune. If I remember well, it's about 2,000 seats, the total capacity of the tribune. But you can see that you can have information. This is the IFC model, not the original format of the model. So also in the IFC model, this is a viewer that you can have also from different type of the software house. You can have information about any object that are included in the models, not only in the proper software tools, but also in the IFC visualization. And what else? Okay, we can go ahead. And so we have a structural design. We develop also the structural design. This was a concrete tribune with roofing steel. So we developed some model and also drawing at the end in order to build the structures. This is the view of mechanical and electrical system. The electrical and mechanical system is quite sometimes is a part of the design that is normally we are not giving big values, but is a very important and it's also critical part of design. Are a little object, a little element that in any case has to be coordinated with the architectural and structural. Architecture is the main is the VIP part of the design, because architecture is the part that the client, the person has the first view, but managing all the other aspects of the design with the architectural views, the expectation of the client is not something that is a secondary issue. So have the possibility to introduce this element in the model from the very beginning, the very initial stage of the project, reduce a lot of problems in a further stage of the project, because most of the time the space for the mechanical electrical system are not taken properly into account in the design. So we are well coordinating the design using this type of tools. These are the soccer field heating system, as I told you. There was also irrigation system, everything that is necessary for a sport facility like like a soccer field. Now there is also another type of this probably is something that for our architectural mathematics, I think that this is something that probably she knows. I would like to knows if this type of approach of the design is known. Is a parametric approach using software, 3D software that has
amazing stadium.
But the stadium is amazing. This is a stadium in Russia, in Moscow. But the design to manage the geometry of this roof is quite complex. The original geometry is already complex. So in order to manage this geometry, it's not possible to do something using and drawing. So in order to manage also the possibility to change the grid, to change all the aspects, we are using Rhino. Talking about software, we are using Rhino together with Grasshopper, and using these tools we can change input data. So we can change the radius of the circle, we can change the space of the grid, and all these changes are managed very easily using this type of tools. And this is the future of the design, especially because now the architectural approach, the architectural shape are very complex, and it's not possible to manage in any other possibility. And also
it's another interesting case study, because also like in Philadelphia, you have a historical part and a new addition. So very interesting.
Yes. And for example, this type of approach to the design can be also used for having the better solution for a tribune looking to the seating arrangement. So there are rules. The rules are the same. So we can introduce the rules in our software. So this is sort of software. And so changing parameters, we can have the 3D model already arranged, already changed, only with big changes, only having changes in input data. This required in the past a lot of time. Now we can do it very easily, and this approach requires a mathematical approach. So it's very important for us now having in our office not only architect and not only engineer, but also mathematics and IT skills, because now the future of the design is these tools. And if you are going quickly, we can know if we would like to approach more complicated design, is necessary to use these modern tools. This is the future. And now this could be also probably managed using artificial intelligence. So probably it's not only necessary to put the input data, because the artificial intelligence probably will give you the input data necessary to develop the design. So I think that in the next future, this will be the solution. And at the same time, using this type of parameter approach, we can also have arrange the structural design. So we can arrange some data using input data, and we can change the spaces of the truss, and we can change the height of the truss. So all the changes are very quickly and very easy to manage. There are rules that has to be put in the design, to put in the system, but this is a very interesting approach that we are looking in our office. And this has been done using also the relationship that we have with the university, especially with the university in Padua. We are in Padua, a historical city close to Venice, and we have a very good university, the second oldest university in Italy. And we are hosting master thesis, or student has to develop the master thesis, and using having this student, having this person in our office, we can also work look into the new technology and new approach to the design. So this is very important for us. Sorry. For example, now we can use software that allow us to look to the best solution in terms of, in this case, in terms of weight of the truss, changing automatically the shape of the truss or the arrangement of the beams in the truss. So the software introducing some rules is looking to the most efficient solution. And so we do automatically. Yes, this is something that is very, very interesting. And from this analysis, we are having drawing, 3D models. So in the models, we are having reinforcement, all the information that before has been developed using hand drawings. And okay, going to the 4th dimension of the drawings, in our using the beam, we can connect the model with the time schedule. It means that our model has been divided in WBS, so work breakdown structure. So is the sequence of the constructions, and the model as inside information related to the phase of the construction. So now we connect two different tools, BIM model with the time schedule software, and we can manage this information in the same way, using the same 3D model. In the same time, so and these construction phases are represented in 3D view, so we can see how the construction can be developed and has been planned during the design. At the same time, the connection between the BIM model to the bill of quantity is possible. So there are tools, proper tools, software tools, but there are also some in-house softwares, in-house tools that we have already developed, in which we can export the bill of quantity, quickly have the value of the construction cost. This is something that in the past has to be done using a person that count the quantities on the drawing. Now there is a direct connection between the model and the bill of quantity. You have to not to know, because probably you know, but in order to underline this aspect, the value of the value of the construction cost at the end is one of the most important things of our job. Develop a good project, a good design not means that there is only a good shape, only a good architect, but the cost of the construction has to be in compliance with the budget of the client. So this is our goal. And to have information of what could be the cost during the developing of the design is a very, very important issue. Otherwise, probably you arrive, and this also happens in the past or is happening also to us, that you arrive at the end of the project, that the value of your design is not compatible with the budget that is in the end of the client. So good design means, good shape, good architectural shape, good structural solution, but to be in compliance with the budget, the cost budget of the client. And using this tool, this result is very, very more easy to reach that than before. So giving a summary, so BIM approach to the design for sport facility, but not only for a sport facility, but for any other type of project, means using 3D models that you can provide you drawings, 3D representation, material information, as a connection with the time schedule, so 4D dimension, also connection with the cost, so estimation of the cost during design, development, and also final project cost, and also to be able to perform a different type of analysis starting from a common data environment that include all the information from our BIM model. The final result of this experience is these are not anymore drawing or 3D representation. Those are pictures of the stadium already built, and it's quite similar to the design, as you can see. Little changes in any case arrive at the end, so never the final construction is properly the same. And as I told you before, we are also using business intelligence application. Now the BIM model can be used to get information using also this type of application. So we can check using different type of information levels. So for example, here we can have information about floors, we can have information about quantity of steel, we can have information about concrete, but also we can have information about time schedule. So now the BIM model is connected also to this type of software. I don't know if you know, there are several, for example, Microsoft produce Microsoft BI, and these are very nice tools in order to check to monitoring your design. I don't remember very well what is the last. Okay, this is another experience that is the future of, and is not only the future but the reality of the design. That probably the music is so high. Now it's possible also to use augmented reality, so using video screen that you can have in your helmet. You can go on the side, you can have the visual representation of the design already during the construction phases. The one that you saw in the picture is Margherita, that we'll talk to you later on, and this is an experience of renovation of a residential building, in which has been applied also this type of approach, not only to design, but using the BIM during the construction phases. And that's all. Okay, this is everything by me. If you have, I hope that you have some questions.
Thank you, Gianluca. I leave a question to our colleagues, no students.
Simone, which is the difference between IFC and BIM? Okay, so I can answer to the question that was in the chat. Oh no, the IFC and BIM. BIM is the means a general way to approach the design. So there are models, 3D models, not can be developed by different type of softwares inside the model that are digital representation of the reality. There will be included a lot of information as we saw before. IFC is a common standard in which this type of models or digital data can be exchanged between different software. This is the difference. So, for example, talking about, okay, probably everybody knows Revit or Tekla. These are softwares. using this type of software, we can develop a BAM model. If I want to exchange the model produced by Revit to a software, to another software, for example, to Tekla, I need to produce an IFC. An IFC is the common data that permit to exchange the software between a BAM model to a software to another. And the IFC is a standard that allow to do this, the international organization that permit this exchange. Other question. Okay, in the chat there is another question.
Just my comment. Cody, no, Linda.
Clear. No, is only to say that is all is clear. So thank you.
Thank you too. Okay, after me there is Damiano, that is in the other room, another meeting room in our office. Damiano now will show you, will tell you another experience related to a soccer stadium. This is the soccer stadium of Udinese that you visited probably last week, if I remember well, something like this. And the soccer stadium was being built 2010 years ago, probably, or something like this. And there is a very interesting also, not only from the design point of view, but also from a construction point of view, because the stadium has been renovating during the soccer season. So it means that during construction phases, Udinese still continue to use the stadium. So with the limited capacity of the tribune, but in any case, also the arrangement of the construction in terms of safety, in terms of possibility to work or not, is being a very challenging issue of this project. But not to anticipate what Damiano would say to you. So I let Damiano to do the presentation. Thank you. No. Okay.
Hi everyone. My name is Damiano Curcuruto, and I'm a reference in Incide engineering for facade and steel structures. Let me start the presentation. Everybody is hear me?
Yeah.
Okay.
And we see well the screen.
See the screen? Yeah. Okay. Just a moment. Okay. So the project I will talk about today is the case history of the renovation for the Friuli Stadium in Italy, close to Udine. This project had the specific intent to renovating a sport facility that is rich in history for the Friulian territory and highly recognizable for its formal features. Toward a structure more closely to the current concept of the football stadium. So this is the picture of the detailed design from the architect. The football stadium is of the stadium of the Udinese Calcio team, a Serie A team of the Italian Football League. And the actor in this project were main contractor ICICOP. The general design has been developed by Area Progetto Udine. ICICOP in this case appointed the company Cimolai SPA for the construction of the steel structures. And our company has been appointed in order to develop the steel structure detailed design. And especially we approached the structural steel review and optimization, the detailed steel design, and the erection design. Okay. The main purposes of for this project of the new Friuli Stadium is to create a modern sport facility. I'm going too fast. Okay. The modern sports facility is safe, sustainable, able to offer a unique experience for all the users, sports players, spectators, media, etc. And contextually continue to be a hallmark positive morphology and the architecture of the area. Some technical data is the category of the stadium that is a UEFA 4A. The total seat number is 25,000, more or less. The concrete structure for a new tribune is a totally of 24,500 square meter. The total project area is 44,000 square meter. The new roof structures with aluminum covering is has a surface of 16,000 square meter, and all the new facade surface in zinc and titanium is 5,000 square meter. This project aims to maintain the historical image of the Friuli with the specific features of the arc coverage of the new tribune. That is definitely the main architectural element that has been maintained. Those are pictures on the old stadium with the athletic track around all with only a main tribune covered with a roof having a main concrete structural arch. The idea of the designer was to remove all the track around of the existing tribune without the roof in order to move the tribunes closer the soccer field and improve a roof for all the rest of the seats. The historical tribune has been maintained and integrated with the new design. So here are some pictures of the existing situation. Sorry, the keyboards go too fast. Okay. Sorry, but I have some problem with the keyboards because probably the wireless is not connected. Sorry. Okay. This is the architectural plan of the new project that show the new configuration of the stadium, which the difference between the two solutions with the tribune now much closer to the soccer field that was in the existing stadium. So here we can see that the existing tribune that has been maintained, and the previous position of the existing tribune was outside the tribune that you can see. All the tribune that you are that I'm showing now with the cursor are the new tribune moved towards the soccer field. So from this section, it's possible to understand that the main concept of the project that was to have the tribune much closer to the soccer file. The existing tribune was 16.5 meters far away from the soccer file for the presence of the athletic track all around the file. So the new tribune now has been designed at only 5.5 meters from the soccer file, and all the seats are now covered by the new roof. What I would like to illustrate today is even the roof structures design that it was in our scope of work. So I'm talking about all these structures for the roof and the facade. This is the cross section that he received in the tender design. So is the previous phase has been for us the starting point. No, the roof of the main structure, as you can see, is a cantilever double truss beam supported by columns in precast concrete, coming spaced each 10 meters. So here you can see the plan. In the tender design, over each column spaced 10 meters, there was a double truss, trussed, and other 7 transversal trusses to provide the roof stability, complete the roof stability of a system cross bracing. This is the 3D view showing the structural system of the tender design. Other main element of the roof are transversal double trusses over the central column and transversal trusses spaced 10 meters that provide stability of the roof and roof bracing system. This is our starting point. Working on behalf of the fabricator with their technical office, so the Italian company Cimolai SPA, it has been developed a new project in order to simplify the structural solution with the aim to simplify the shop works, simplify the assembly work on site, reduce the timing, construction work, and simplify the installation on site. So here we can see that we reduce the double truss in a single truss, and we implement a lot of the optimization. This is a 3D view showing the structural system of the final design with all the changes. The single main truss over the concrete column, the edge beam not trussed, reducing number of the transversal trusses, and the optimization of the roof bracing system. So it's pretty different. The new structural solution has been validated in order to check the structural behavior in terms of stiffness and deflections. The new engineered solution demonstrates the same behavior in these pictures. So we achieve our scope of value engineering for the fabricator. Another important change from the tender design that it has been developed in the final edge of the truss. So these final parts. In order to obtain the best architectural view from the internal side of the stadium, instead to have the trusses with ceiling in the lower part, a single beam exposed has been used, and a polycarbonate roofing has been installed. So this is here we have a comparison between the two architectural solutions. In the tender, there was a truss edge with a round shape covered by a polycarbonate on the top and the wire mesh ceiling on the bottom. The new solution have an exposed beam with white colored with polycarbonate giving more light and to the social file. What I would like to illustrate today is even the roof that we designed. Yeah. This picture shows the site during the installation of the roof structure. It's possible to have evidence of the edge of the beam and the starting of the installation of the new aluminum ceiling on view. A beam structural model has been developed in order to design and coordination, in order to coordinate the architectural aspect and other disciplines. The detailed calculation has been performed to check the cantilever beam and its our connection to the truss. Okay. This is a detailed drawing of the cantilever beam obtained from the 3D model that I showed before, using the software Tekla structures in this case. And from the beam model, general drawings and detailed drawings can be obtained. This is how we did. The connection between the trusses is was a very critical issue to manage, because we have a lot of items that have to be coordinated with a precast fabricator. And all the loads of the roof are transferred to the concrete structure by only these two elements. The central element is composed by a cross section of welded plate. So this is another optimization that we did, in order to have the possibility to join easily the member of the trusses and for leave the place for the anchor bolts. A FEM model of the members has been developed in order to check the stress and to evaluate the buckling coefficient. The connection between the trusses and the connection and the concrete column is the central element that compose that I illustrated before. And here we have some detail extracted from BIM, the detail, the FEM model, and the 3D view from the Tekla structure models. This section is an annular section in order to allow the accommodation for the down pipe coming from the roof. So we was able to coordinate even these aspects. A full FEM model of two sectors of the roof has been developed. Two models have been developed, one for the sud and one for the north tribune, that are structurally the same, and one for the main tribune, the central tribune. This was necessary because the structures are separated by a seismic joint, more or less 10 centimeters. So this is another picture of the FEM model for the typical model that we developed at the beginning. And here we can see the FEM model done to find the maximum displacement outward. Here we can see a full 3D structural beam model that for a portion, a typical portion close to the arch has been developed. And this is has been used for the architectural and system coordination with the existing concrete structures for the arch and in order to coordinate the facade at the end. So here we can see the typical model of the roof and the connected facade. In the lateral parts, we can see the secondary structure of the facade that will be coordinated with the arc. But in the next picture, I think that we can understand better. So here we can see it has been developed a laser scanner of the arc structures in order to be coordinated with the facade used in the beam model ported as a reference. This is a view from the lower part of the structure with at the beginning of the installation of the ceiling. You can see that we follow in the beam, with the beam we respect the reality. Here we can see a picture of the structure with the nearest picture extracted from the model. As you can show, the job effectively done. And the structural element that connected the existing arch roof in the new roof was particularly complicated element to be defined, because as to satisfy the architect requirements and all the to solve all the coordination aspects. This has been complicated, related to the complex shape even of the external facade, developed in the double curvatures in some parts that need a previous analysis of discretization. In addition, it should be respect the facade joint, and all the alignment needs to maintain a fixed distance from the existing arc. This operation needs before to achieve the geometrical information, as told before, from the site of the existing construction that need to implement the final geometry of the structures. Here we can see the final result before the facade installation. Another aspect that we develop is the erection design. The erection design of the facade close the existing concrete arch, all of the installation of the steel structure, studying a simply optimized solution using a simple lifting crane positioned in the external side of the stadium without particular interfaces with the soccer file. At the end, the secondary structure of the facade has been realized as per facade geometry discretization and following all the restraint of the existing elements, requirements of the existing and setting steel of the fabricator. Here we can see another picture that represents the final installation. Okay, other secondary and complementary structure in the stadium, for example, the support for the light, the metal catwalks under the roof, and the secondary structure for the maxi schermo. This is the metal catwalk that go around under the polycarbonate roof. This is the maxi schermo that has been supported by steel structures connected to our main structures. Okay, yes, another general information concerning this project is that the stadium is not only a stadium. Basically, the architectural design provides a modern solution even to related the space destination in order to use the stadium capacity. The concept is to dedicate the indoor spaces under the tribunes and covered from roof and facade to commercial spaces, bar, skylight, press area, meeting area, restaurant, and other public area. Direction design is another important part of the design because need to solve a lot of critical issues related to the context of the site. This part of the design has been developed in order to define the site organization, the assembly at ground of the elements, the erection procedures and tools needed, and the stability of the structure during the provisional phases. Each erection phases have been properly studied and analyzed, taking into account the crane capacity and lifting tools required. In addition, the management of the data extracted from the BIM model that give advantages and benefit in this purpose. This is another sample of direction design and how the site strictly follow the project. We can see in this picture. Another very important aspect of this project is that the construction has been performed maintaining the availability of the stadium for the matches. So the capacity of the tribunes has been obviously reduced of the existing arc tribune that have been maintained operative. And basically, the main concept is that it is not possible that as affect to the main requirement is that it was not possible to have affect to the schedule of the championship. So it was a very strong challenge. This picture shows the sequences on which all the construction has been developed. First, the south and the main existing tribune has been demolished, and after erected the precast tribune. In the third phase has been installed the precast element of the seats, and in the last phase has been installed the steel structure of the roof. This sequence has been repeated for each sectors. From these aerial views, it's possible to understand better the construction sequence. Demolition of the north tribune and the erection on precast tribune structures and roof steel structures. Demolition of the main tribune plus erection of the precast tribune structure plus roof steel structures and demolition of the sub-tribune with the main sequence. The works has been developed maintaining the stadium, the availability of the stadium for the championship. Here we can understand better the sequence. And you can see we try to use all the spaces, the available spaces outside the stadium in order to use for the available space for the crane. So all the football matches could be go, and the soccer file could be used. These are pictures was showing the situation of the stadium during the work and almost at the end. Here we can see two pictures taken during the first official match in the stadium. Yeah, probably we have a video that is not working. Sorry. And another one of the beginning of the match, some Sunday in Sunday, the last sub-tribune is under construction, and it has been completed some months ago, some months later. So summarizing, those are pictures showing from the aerial view, which describe the progress of the work until the status of the almost the completion of the latest tribune. This is a short video that can describe the erection sequence of the installation on site under the completion. The aspect of continuous activity of the Football League is an aspect that generates a lot of critical issue in order to the installation phases on site and for construction company that had to arrange particular studies in order to perform the storage elements, define the best installation sequence, respecting always the time schedule. So has been the more restraint that we had. The quality of the video is not the best, but I think that we can understand how the site has been implemented. You can see that 2 tribunes have been completed and the match is working.
Sì, si vede. We had in our classroom, I think last May, I don't know, I don't remember, but Archest that worked on this project on the
Archea.
site. Archest.
Yes.
Udine, yeah.
In the previous phase, yes.
Absolutely. We had also Archea. Marco Casamonte is a friend of mine.
Yeah. They developed the architectural solution of the facade, no?
Yeah.
It is very, very, very nice.
Cangiante, non so come si dice in inglese. Cangiante.
Okay, as already illustrated from Gianluca in the previous presentation, even in this project, the BIM has been properly used in order to support all the project stakeholder and all the information that they need in order to manage issue of different and various typologies during each phase of the design. In this case, especially in this case, the BIM has been used to the design coordination of the structure facade, the steel structure of the roof, and the map system to choose the best solution, avoiding mistake and reducing the time development. To keep, we worked for the fabricator, so to keep under control all the quantities and the total budget for the structures, and in order to coordinate the design and the production of the steel fabricator. The format to exchange the information used, even in this case, has been the EFC format file. The matching the EFC is possible to do clash detection, the check of the implementation in the BIM model, and other type of activities. The weight of the file exchange must be light, because all the stakeholders need to use this file for coordination and to cloud export in the EFC directly the parameter you desire. You can even always have a view of all the data and all the information that the project has to follow. Here we can class structures. Here we implement all the information that we need, the fabricator need, the precast fabricator need, etc. So you can see the information in the lateral part. When you click in any elements. So EFC is not only a geometrical reference, but is a full reference, a full information reference. You can see material, type, geometry, and you can decide what you want to exchange with the other stakeholder that you have to coordinate any aspect. Okay. Concerning the BIM, used in the right way could perform in management of any type of data. As told you before, quantities, deadline, cost. Here represented some pictures whose describe a customized interface that graphically represent the total takeoff quantity of the steel structure managed. The quantity can is maintained under control from our technical office for the fabricator, for the steel fabricator, exporting periodically the list and reports directly from the BIM software, in this case Tekla, and directly connected with the interface with the main purpose to visualize anticipate any issue. For example, basically here we have the analysis done for the previous data with Microsoft Power BI. So we can graphically have a dashboard, that allow to understand how the element is being used in different quantities. So we have a lot of rondelle. Okay, that's all. I hope that the presentation has been interesting for you. And I don't know if you have any question or if you prefer to do a break.
I think I would like to do the break. I would like to do the break.
Okay. After me is here Simone Oro. And after the break, we can continue. So
how long we are in the break
long?
now is 11:05. I don't know, 11:15, 11:20, 15 minutes of break is okay for you? 15 minutes?
Okay.
11:20, okay.
Okay. Thank you.
Thank you.
Scusate, ma mi hanno appena telefonato. Ci vediamo dopo la pausa del caffè.
Ah.